Okay, guys. Okay, guys. So just to be clear, I'm gonna collect the U sub take-home quiz in a little bit. I hope that was a nice experience. Good. A little warm up for a Friday. Tomorrow, do not come up to this classroom. So think about where you're going to be 6 tomorrow. You're going to go right to the library. That's where we're going to be tomorrow. Okay? So we're only displaced one day, which is pretty good considering the testing going on down here. So tomorrow we're going to go to the library and we'll have our class. And Friday is the test. If you want to go to extra help tomorrow, because there could still be people in here, Miss Vittoria was kind enough to let us use her room 216 after school. So once I finish my bus duty, I'll go to room 216 if anyone wants to stay after tomorrow for extra help. Okay? Friday we're in here, yeah. So it's just, I don't know. So for the do now, today we're gonna go over the do now because I purposely picked, remember those tricky U's with those U's where the du was a fraction, so it really was in your best interest to separate it, split it apart and do it. So I gave you 3 examples like that for the do now you can work on. I'll go around, I'll collect the quiz, and I'll check to see that you did your integration leading to inverse trig. That day 66. So I'll do that while you're doing the U sub. After we go over the homework, then I'm going to let you work in groups on the review sheet. Okay, let's go over some of these. These are 3 challenging U sub problems. Yeah, there's a reason I'm doing these. Yep. All right, well, what's the first thing you would do? Even before you have a clue, what would you do first? Pull out the what? 1/2. Nice. 1/2, the antiderivative of sine of the ln of x over x, right? Now, who gets to play the role of u today? Ln of x, inside function. Now, what is du? 1 over x dx. Whenever you have the u is either ln of x, square root of x, or 1 over x, du is going to be a fraction. And that's why I think it's helpful in these situations for you to pull this apart. So to write it as sine of the ln of x times what? Instead of divided by x, what can we multiply by? 1 over x, right? Or x to the negative 1, right? Isn't it? And the reason you do that is so that you can see your factors of du. When you write it as a product, I think it's easier to see. Okay, so look at what you got. Do you have your factors of du? Yeah. So we just rewrite it. And when we rewrite it, it's the 1/2 the antiderivative of, no, that's taking antiderivative, we're just going to rewrite it first. Sine of u, and the rest of that is just du. That a little higher. Okay, now you just got to know, is the antiderivative of sine cosine or negative cosine? Negative cosine. So we get negative 1/2 cosine of u plus c, or negative 1/2 cosine of the ln of x plus c. These really aren't that much more difficult. You just have to be aware, oh yeah, with the fractions, maybe I should write it as a product so I see it. Any questions on this one? Pulled out the half. We had assigned our u. We have our factors of du. Bam. You loved it? You want more? Here we go. Okay. The next one, what are we going to do first? Thanks. See, I'm purposely putting more of these in the denominator so you know what to pull out front. You guys are good at that. Okay, so I'm integrating secant squared rad x over rad x. Okay. Tricky U number 2. What's U going to be? Rad x. Do you remember what du is when 1 over 2 rad x? Because it's 1/2 x to the negative 1/2, so 1 over 2 rad x. Nice. Now, with these again, it's nice if you first rewrite it as a product. Secant squared rad x times, yeah, we do, but just to rewrite it, 1 over rad x dx. All right. You don't need to do, if you can see it, you don't have to do it this way. I just try to give you a way to help you. So yeah, what do we need again? We need a 1/2 on the inside and a 2 over 1 on the outside. All right, time to rewrite it. So on the outside, 2/3, got the antiderivative of secant squared u du. Now, you got to know what the antiderivative tan of u, okay. Now we can switch it back to x's. So it'll be 2/3 the tan of rad x plus c. Okay. So we factored out the third. It really does help though, oops, sorry about that, if we write it as a quotient. Check it out. Any problems with this one? All right, got one more here. So look at the last one. Think about what you're going to do first. Okay. I'm going to pull out the 1 over pi. So we have e to the 1 over x squared dx. Okay. 1 over x for our u. Now you can think of that as x to the negative 1 if you want to, but we needed the du. What is that going to be? 1 over x squared? There we go. So what we have so far, if I pull it apart, I've got an e to the 1 over x times 1 over x squared dx. You need a negative 1. Okay, so on the outside we have a negative 1 over pi. And in terms of u and du, what do we have? U du. Nice. All right. So now we just have to know what is the antiderivative of e to the u du. E to the u plus c. We did it. Now we just have to put in 1 over x for the u. Isn't that exciting? Those three, nothing to be scared about those three, the rad x, the ln of x, and the 1 over x. Just be on the lookout for them, you know? Okay, homework. I did put the answers on the back of your do now, so you can check that. I think there was an error at number 8. Yeah, it's supposed to be x to the 4th under the radical, not x to the 5th. Which one? Number 8. Start with that one. Okay. Number 8, there's no constant to pull out. Okay? first thing you check when you go to integrate a fraction is, do I have enough x's in the numerator? And what I mean by that is, you look at the denominator, the inside function is 1 minus x to the 4th. If I make that my u, would I have enough x's up here to have du? What would the derivative of 1 minus x to the 4th be? Good, negative 4x to the 3rd. So I would need x cubed up top. I've got it. Yahoo, it's not going to be inverse trig. Okay? So don't worry about getting a 1, or even though you have 1, you don't have to do any of that. That's only when the degree of the numerator is not great enough, when you don't have enough x's up here to be du. So we've got it. So it's going to be normal u substitution. So we're going to let our u equal 1 minus x to the 4th. And as you said, du is negative 4x to the 3rd. What do we need inside? Negative 4. And then on the outside, negative 1/4. Kind of squished over here. So I have negative 1/4 the integral of. Now I'm going to replace that negative 4x cubed dx with what? Where's all this? That's just du up there. And what about the denominator? U to the half. All right. So is this an ln? To be an ln, this would be du over u to the 1st. All right? So I am going to be able to use the power rule. Okay, as long as it's not du over u to the 1st. Yes? Oh, okay. Yeah, you're already doing it. Yeah, but before you can actually get the antiderivative with the power rule, what do you have to do first? Yeah. So you rewrite it as u to the negative 1/2 du. And then you're going to get what you said. I have to go ahead and yeah, now you can use the power rule once you brought it up. So when you the first thing you do is you add 1 to the exponent. Negative 1/2 plus 1 is positive 1/2. And then you have to multiply by the reciprocal of the new exponent. So we're going to multiply by 2, positive 2 over 1. So we get negative 1/2 square root of 1 minus x to the 4th plus c. I think on the key it said 5 here. It's 4. What's that? Number 1. Need to see that one more? Oops. There we go, and I'm leaving that for you. Okay? All right, so number 1, what are we going to do first? Pull out the 12. I like it. I have to, because it's in the way. I should just move it. All right, so 12 times the antiderivative of x cubed the square root of 16 minus 9x to the 8. Let's see if we need to use inverse trig or not. You look at what's inside here in the denominator, and if this is my u, what power of x would I need in the numerator? 7. I would need next to the 7th. Not enough x's. So I am going to have to use inverse trig. Okay? Oh, well, inverse trig, first step, once you realize that's what it's going to be, the constant in the denominator has to be a 1. Right now it's a rad 16. Okay? So we're going to factor it out. And we're going to pull it all the way out to the front. So out front, we have 12. I'm going to leave it rad 16 so you see it. We'll make it 4 later. Okay? Now this is where you have to be careful. You know, when you factor under a radical, okay, just forget about the radical. Just pretend it wasn't even there. Just factor out the just leave the radical on each factor. Okay, but just factor it out. So if you factor out a 16, what goes here? 1, 9x to the 8th over 16. You can see that when you distribute the 16 back, you'll be right back there. You just divide each term by whatever you pulled out. Okay, so now we have a 1 there. What's the other special step after we get the 1? Identify u squared. So what is u squared going to equal? 9 over 16x to the 8th. Right. So what does that mean u equals? 3/4 x to the 4th. So what does du equal? 3x to the 3rd. Wow. Okay. So do you know which one this is? Do you know which inverse trig function this is? Sine. So that one we don't have to, it's just the inverse secant you got to worry about both du and u out front. But for the inverse sine, just make sure your factors of du are in place. So what do we need? A 3, right? So if I put a 3 inside, I multiply by 3 inside, I have to divide by 3 outside or multiply by a 3rd. So what is all this? If I multiply this out, what do we have as a coefficient in front of the integral? 1. So all this, there's got to be a way I can do this. Okay. All right, so I'll just write it here. So this just equals 1, you don't have to write that, times the antiderivative. In terms of u, we've got 3x cubed dx, which can be replaced with du. Nice. And in the denominator, the square root of 1 minus 9x to the 8th over 16 is just square root of 1 minus u squared. Now, what is the antiderivative of du over the square root of 1 minus u squared? Inverse sine of u. So our answer is the inverse sine of 3/4 x to the 4th plus 6. 4. Is that all right? Oh. Okay, number 4. Oh, what can you pull out of number 4 if you look at it closely? It's really a 3, because you can pull out a 12 in the numerator and a 4 in the denominator. So you're really pulling out a 3. So we've got 3 times the antiderivative of x squared over x cubed square root of 16x to the 6th minus 1. What? No, I know. This one I wind up putting it back. But I just want to kind of be consistent, just do the same thing. Now, the question is, am I going to have to go inverse trig? Look at what's down here under the radical. In order for me to have du up top, what power of x do I need? 5, x to the 5th. Not enough. I'm going inverse trig, bless you. Okay? So we're going to go with the inverse trig. The nice thing with this problem is, what's the nice thing? You tell me. What's already done for us? Bless you. It's already a 1. Okay? So we don't have to do that. So what comes next then? You don't have to factor out anything. It's the constant that has to be a 1. I bet a lot of you factored out the 16, right? Yeah, I know. You don't do that, right? It's just you want the number, the one that without the x's, to be a 1. So we didn't have to factor anything out, so then what would our next step be then? Identify u squared, and that equals x to the 6, so u equals, nice, and then du, 12x squared dx. And which one is this going to be this time? Inverse secant. And with the inverse secant, you have to make sure that you have du up top and a u in front. So that's why Audrey was saying we shouldn't have done that. But it's fine. So what do we need up top to have du? We need a 12. Okay? But we also need in front of the radical to have a u. So what do we need down here? We need a 4. So what did I really just put inside? Inside I really multiplied by 12 over 4 or 3, right? So now I have to compensate outside by dividing by 3 or multiplying by a third. So we really just have 1 outside times the antiderivative. And now we've got our du over u times the square root of u squared minus 1. Which everyone knows is inverse secant of absolute value of u plus c, and then we put that in there. Okay. Anything else? Okay, so now you're going to work on the review sheet. Let me tell you guys, you're so into the u sub mode right now that when you have a problem without u sub, I think it just makes you crazy. If you look at the first couple, there's no problem. Yeah, you just integrate term by term. It's just powers of x. It's not powers of x to the 7th minus 3 or anything like that. It's not compositions of functions. So the first two, no u sub, just integrate term by term, okay, using your power rule. Then you'll get back to the u sub. So work together, get in groups. If you think someone's smart, just put your chair up next to them and put it down.